Let's take a look at section 10.4, probability of disjoint and overlapping events. In this section, we're going to look at finding the probability of multiple events happening in the same time. In our first term right here, let's talk about a compound event. So hopefully we realize, hey, a compound is like when there's more than one. So when we talk about an intersection or union, or intersection of two events. And when we think about an intersection or union, things tend to overlap. Okay, so that will take us to our next term right here of overlapping events. When two events have one or more outcomes in common. And, we've mentioned stuff like cards. Okay, so when we think about like would be an overlapping in when we talk about cards is like what is the probability of, let's say, a jack and spade being chosen? Because if you think about it, remember we have four jacks in a deck of cards, right? But we also have several spades, right? We have 12 different spades there, or sorry, 13. So there's an overlap because there is at least one. There's a jack of spades, and in the whole amount of spades that are possible. So right there, that would represent the overlapping events. Okay. In the next term, let's go to disjoint or mutually exclusive events, and that's when two events have no outcomes in common. Um, the probability of my shoelace being untied and the probability of uh, me getting an A in class. They have no, you know, those two events, the probability of either or happening, there's no exclusivity. All right, so they have nothing in common. If one happens, it does not affect the other. And that would be your disjoint or mutually exclusive events. So the core concept, okay, as we move along, this right here, you really do need to understand the probability of compound events. And there's two different ways of looking at them. Okay, so I would definitely say to memorize this stuff right here. It makes things so much easier. And what are we looking at? Okay, in the first one, it says if A and B are any two events, then the probability of A or B, okay, probability of A or B is equal to the probability of A plus the probability of event B. And then this right here, this minus probability of A and B, this would be the overlap, okay? And I'm going to go ahead and put right here, overlap. So we need to subtract the overlap um, because if we don't, then the chances of something happening is higher than it really should be. It's not realistic, and it does not um, get us the correct percentage or probability. All right, so if we have two events, especially if they happen to be overlapping, then we need to subtract the overlap from in order to get the correct answer. In the second one right here, we use if we have two events that are disjointed, okay? And then once again, we have probability of A or B, and then we just take the probability of event A, and then we add the probability of event B to get our answer. So let's put this all together, and let's take a look at number one. So right here we have events A and B are disjoint. And then they give us the probability of A and probability B, and then find the probability of A or B. So remember in the beginning, or what I just mentioned just a few moments ago, we take our equation. We got a probability of A or B, and because this happens to be disjoint, we're just going to go ahead and take the probability of A plus the probability of B. Okay, very simple right here. We go ahead and take 2/3 and then plus 1/6. This right here, if we get ourselves common denominators, we end up with 4/6. So that becomes 5/6. Right. So now when 5/6, that's a ratio. We want to turn that into a probability. And so if you go ahead, or sorry, yeah, and we're used to probability being um, using decimals. So let's go ahead and change that to 0.83. And then that equals approximately 83%. So out of those two answers, I believe, is what they'll be looking for in big ideas. All right, so let's go to number 2. In problem number 2, they give us the probability of event A is 0.8, the probability of event B is 0.05, and then we have the probability of A or B happening, which is 0.6. And it says find the probability of A and B. So this right here, hopefully we have two events. They look like, hey, they are going to be overlapping. And how do I know? Specifically right here, probability of A and B shows would be in the equation of overlap. So let's set up our equation. We have, remember, the equation goes probability of A or B. That's equal to the probability of A plus probability of B minus the probability of A and B. So if we know the equation, then it's easy just to, plug these numbers in, pop them in place. Probability of A or B, right here we have 0.6. The probability of event A is 0.8, plus the probability of event B is 0.05. And then we have the probability of A and B. And let's go ahead and I'll just go ahead and write that down. A and B. So now, just go ahead, use your calculator, solve things out, and we'll get that variable by itself. All right, so if we take 0.6, and let's subtract 0.8 to both sides, and then also subtract 0.05 to both sides, what I see here happens to be negative 0.25, or 0.25 is equal to the negative probability of A and B. So the last thing we have to do algebraically is divide both sides by -1. And so what do we get? We should end up with a positive 0.25. All right, so positive 0.25 right there is the probability of A and B, the overlap in this instance. Well, we know how to use things when it comes to this equation, but let's put it all together now in a semi-real situation here. So let's take a look at exercise 3 to 6. Okay, it says a vehicle is randomly selected, randomly chosen from a parking lot. And some important information here. It says the parking lot contains 3 red minivans, 2 blue minivans, 3 blue convertibles, 1 black pickup truck, 3 black motorcycles, 1 red motorcycle, and 2 blue scooters. And so we want to find the probability of selecting the type of vehicle. Problem 3 says, what is the probability of finding a red vehicle or a minivan? Okay, well, let's split things up right here. Let's divide things. Let me organize some of our info. We have 3 red minivans. Just going to go ahead and organize information. We have 2 blue minivans. We also have 3 blue convertibles, 1 black pickup truck, we've got 3 black motorcycles, 1 red motorcycle, and then we have 2 blue scooters. So I'm going ahead and just put all that stuff together right here. And if we're trying to find the probability of a red vehicle or a minivan, well, let's take a look. It looks like I have a red minivan and I've got a red motorcycle. So if we think about the total number of red vehicles we have, there's a total of 4. But remember, we've got right here some that are red. We also have some that's also a minivan. So there is this overlap that happens to occur in this problem. So let's see how we could put all of that together to get our answer. Remember, our equation is the probability of A or B. Okay, A being the red minivan, or let's say red vehicle, the probability of a minivan, which happens to be V. Okay, that right there is equal to the probability of the minivan, which says A, the probability of, probability of the red vehicle, once again, is A. Probability of the the minivan is probability of B. And then we have the probability of the overlap, A and B. So I think it's important for us to first figure out, well, how many vehicles do we have? So that's why, look, if I have all my information laid out right here, it looks like we have a total of 15, okay? So we got 15 total vehicles. And so the probability of it being a red vehicle, we have a total right here of 4. Right, so it will be 4 out of 15. The probability of it being a minivan, and let's see how many minivans we have. I've got 3 red, 2 blue, and that looks like it to be it. So we have a total of 5 minivans in this lot. So we've got, I'll put 5 over 15, and that should be 4 over 15. There is the overlap of events. There is one red motorcycle that is also, there are 3 red minivans that are also red. So we need to subtract that amount right here, and we're going to subtract 3 out of 15. And so now we can go ahead and find the probability of red minivan or red vehicle or minivan. I'll go ahead and just put that right there. And that's going to be equal to, well, luckily we have common denominators. And so we just go ahead and add all of this together. 4 plus 5 is 9 minus 3. That's 6 over 15. Okay, and that simplifies down to 2/5, which equals the same thing as 0.4 or 40%. All right, so now we've put all that information and figured out that probability. So 4, let's go to problem number 4. The setup is pretty similar. We have the probability of a scooter or a black vehicle. We'll go ahead and put A for scooter, B for black vehicle. So when we go ahead and do this, what is the probability of a scooter? So let's find out how many scooters we have here in this list. It looks like we have a total of 2 scooters. So we're going to go ahead and put 2 out of 15. And then let's go ahead and figure out, well, how many black vehicles are in this lot? And there is a total of 4 if we take a look at everything that is right here. 1 black pickup, 1 black motorcycle. So that would be the second event. So we'll put 4 out of 15. Are there any overlapping right here between scooters and the black vehicle? No, because the scooter happens to be blue. So there is no overlap. This right here is a disjointed event, and we'll go ahead and add this together, and we end up with 6 over 15 once again. So we go ahead, let's simplify it down, and then we'll write it as a decimal. And if need be, you may need that as a percentage, which is 40%. Let's take a look at problem number 5. So this one right here, we have the probability of a black vehicle or a motorcycle. And so let's check this, put it all together. Black vehicle will be event A, motorcycle will be event B. So the probability of that black vehicle we have looks like is, hold on, let's set this up. For a black vehicle right here, there's a total of 4, so that'll be 4 over 15. We have the probability of a motorcycle here, and there are a total of, let's see, we have one red motorcycle and 3 black ones. So that's a total of 4. So that'll be 4 over 15 as well. And do we have any overlap? Well, it looks like, we have, we got 4 black vehicles and then 3 of them happen to be motorcycles. So there is an overlap right here. So let's go ahead and I'm going to put minus 3 over 15 for our overlap. Let's get our probability right here. All of this will end up equaling, looks like 5 over 15, which is equal to 1/3. And hopefully we understand that 1/3 is 33%, okay, or 33.3333%. All right, so hopefully you understand now what ends up happening when we do have overlapping events and we're trying to find the probability right there. So let's go ahead and move along and take a look at number 7. All right. It says, during a basketball game, the coach needs to select a player to make the free throw after a technical foul on the other team. There's a 68% chance that the coach will select you. It's probably pretty important. And then a 26% chance the coach will select your friend. And it says, what is the probability that you or your friend is selected to make a free throw? So the probability of you and your friend, that will be probability of A and B. I think the big idea now is, are these events disjointed or is there an overlap there? You shooting a free throw, your friend shooting a free throw, one doesn't have an impact on the other. Okay, so it looks like, look, if we were to go ahead and put this together, we have event A would be you, we have a 0.68, right? That's 68%. The probability of your friend, you've got yourself 0.26. I'll say that there is no overlapping right there. This is a disjoint. So we'll add them up and you end up with 0.94. Okay, we have disjointed events, so that's all we need to do. And this ends up equaling, there is a 94% chance that you or your friend is selected to make the free throw. Are they going to make the free throw? That's another story. But it's about at least getting selected to make that free throw. Take a look at number 8. Two-sided die. Our roll, find the probability of rolling the same number twice. So let's think right here. We got event A is one dice. The event B is the other one. And so if we think about rolling a dice, the first die doesn't really matter, right? There's 6 numbers on a dice. And so whatever number we get, you have a 1 out of 6 chance, event 1. In event 2 right here, well, you have to get that same number that you rolled the first time. So then with the second dice, you have a 1 out of 6 chance. So the question is, well, is there any overlapping events right here? There are none. Okay, they're too disjointed. Rolling one dice does not have an impact on the second one. So right here, we can go ahead and keep this as is. But now, I guess the key thing is this the correct setup? Because once again, does the first die have an impact on the second one? I'll say it doesn't, right? Whatever happens the first time doesn't matter. It's what happens the second time. And so all you really have right here in this instance, I'll say, is you have a 1 in 6 chance of rolling the same number twice. Okay? Because the first roll does not affect the other one or have any impact on the second one. Okay, so we actually will not use the setup right here, and we end up with 1/6. Number 9, here's a good one. We've got, out of 120 students, 90 of them can chaperone the homecoming dance or the prom. Now take a look right here. Homecoming dance or prom. All right, let's think. Remember, in our equation, where would that end up being? Next up, we have there are 40 parents who can chaperone the homecoming dance. Okay, so 40 for homecoming. We have right here 65 for prom. And then it says, what is the probability that a randomly selected parent can chaperone both homecoming dance and prom? Not or, it's both. All right, so we have to put all of this together. Let's come up with, we have our equation, right? We have probability of homecoming or prom, right? That's how we usually always start this off, homecoming or prom. So then what is the probability of homecoming? I'll just use H for that. And then the probability of prom. Now there is some overlap right here because they're saying that there are some that could chaperone both. So we're going to have to subtract that, and that's the probability of homecoming and the prom. So let's think, where could we plug things in? Okay, it says 90 of them can chaperone the homecoming dance or the prom. Now we have to remember that we have a total of 120 student parents. So that 90 should go into the first spot right here, and we'll put 90 over 120. In the second sentence right here, the probability of homecoming happens to be 40 out of 120. And then we have the probability of prom parents chaperoning, and that would end up being 65 out of 120 total. And so we need to figure out this last part, the overlap. How many can do both? So all we need to do is let's get that by itself as though it is a, as though we treat it like it's a variable. So we'll subtract 40 over 120 to both sides, and let's subtract 65 over 120 to both sides. So if we go ahead and do that, adding those two, that ends up being 105, right? So if we subtract 105 over 120 to both sides right here, I'll end up with negative 15 over 120. And that's equal to negative P, H, and P. And what the heck is that, you may say? I wonder myself. So let me go ahead and fix that up. So the probability of homecoming and prom. We don't want negative variables, so we got probability of homecoming and prom. We'll divide both sides by -1 or multiply both sides by -1, and now we'll end up with a positive 15 over 120. All right, and so that right there, we can simplify that down to 1/8, and maybe you know your fractions and decimals very well, and that becomes 0.125. So if we take this as a percentage, you got a 12.5% chance of selecting a parent that could do both right here. All right, one last problem, number 10. And these problems tend to be challenging. I think the easiest way to do this is to organize your information, okay? And I'll show you, we'll organize it first by using, like kind of creating a tree. So football team scores touchdown. The football team scores a touchdown first 75% of the time when they start with the ball. Okay. And then it says right here that the team does not score first 51% of the time when their opponent starts with the ball. So the team who gets the ball first is determined by a coin toss. And then the probability that the team scores a touchdown, or what is the probability? So we have to think about what are some of the events that we have here. Okay, we have event A. Let's think about that first. So let me go ahead right here. I'll put event A. And event A would be, let's think as the coin toss. Okay, so we'll put coin toss, or I'll just put coin up above right there. And then we have the probability of event B. And event B, it's all about scoring, right? If you think about it, they're talking about two things. You get the coin toss, you win the coin toss, you score the touchdown, or you don't win the coin toss and you don't get a touchdown. Well, in event A right here, you got to think, well, what is the percentage of you winning a coin toss, right? There's only two things, outcomes that could happen. You could either win the coin toss or not. And a coin has two sides. So I'm going to go ahead and put right here, let's say we have the ball. And how do you win the ball from the coin toss? And we'll say you have a 50% chance or a 0.5% chance, right? That makes sense because we're talking about a coin, two sides. So in event E or event A, either you get the ball, right? And I'm going to put you right here. Either you get the ball or your opponent gets the ball. And I'll put opponent down here. So that splits it up. Ball, 50-50 chance. Okay. So now in event B, it's whether or not you score after you get the ball. It says the team who gets the ball first is determined by the coin toss. Oh, let's go back a sentence before that right here. And it says that a football team scores the touchdown first 75% of the time when they start with the ball. So what happens? 50% of the time, or sorry, 75%, you will score. That means that 25% of the time, you're not going to score. And here's how we're going to determine. Let's say for event A, we'll go ahead and say that this is, we'll put up right here. The outcome you want is A. The outcome you do not want for the other one, opposite, would be A with the bar over the top. Okay. So then let's go next up. As we go over here, for scoring, that's what we want. So we're going to go ahead and put B, and then we'll put B with the bar, which is the opposite of scoring, which is not scoring. So now let's go to the opponent section. Okay, for the opponent, so that means that right here, the team does not score first 51% of the time. So that's why we're going to go down for our opponent. Let's say they didn't get the ball right here. And so we're going to put score and not score. Okay, but then they say the team does not score first 50% of the time when their opponent starts with the ball. So let's go ahead. What ends up happening is I need to put 0.51 right here for not scoring. And then up above, what's the percent that they do score? It's going to be 0.49. Right, and then we have B right here for scoring, and B with the bar for not scoring. So what is, now the question is, what is the probability that the team scores a touchdown first? Well, what I care about is scoring the touchdown. So let's think. The numbers I'm going to highlight. For us, for U, we have a 50% and then 0.75%. And so what I'm going to do there is go ahead and multiply the two together. Okay, the probability of A and the probability of B. So let's go ahead, and I've got put 0.5 times 0.75. So that is the probability of us scoring, you or your team. But remember, on the flip side, the opposing team can score as well. So the numbers that we need to evaluate right here for the opposing team scoring, I'm going to go ahead and highlight, is they got the ball toss 50%, scoring is 0.49. So the second event right here is going to be, we have the 50% times the 0.49%, or 0.49, sorry, not as a percent, if we're going to say a decimal. So that would be the opponent. Okay, so we have the probability of both. Multiply them, add them up. So 0.5 times 0.75, we have 0.375. And then we have 0.5 times 0.49, and that is 0.245. So let's add the two together. And we have a 0.62 as our answer. So what does that tell us? In the end, 62% of the time, the team that gets the ball first, they end up scoring. All right? Whether it's you or the opponent. There you go. We found some of the probabilities right here of disjoint and overlapping events. Make sure, try those problems out, practice them. All right? Give me a like, give me a follow or subscribe, leave a comment. I'll make sure to answer that for you. All right, have yourselves a good one.